On October 21st, 2025, on this date, is our third confirmed interstellar visitor, 3I Atlas, getting dangerously close to our Sun right now. 3I Atlas is slicing inside Mars's orbit, accelerating toward perihelion at nearly 68 kilometers per second. In mid-October, just as telescopes go blind behind the Sun, Atlas plunges into the most turbulent part of the solar wind, totally invisible from Earth. The questions pile up, the instruments power down. Before the blackout, make sure you're subscribed. We'll drop the first post-conjunction light curves, spectra, and polarization checks the moment 3I Atlas reappears. No hype, just clean signals and what they mean. What happens when a possible 5 to 50 kilometers nucleus from another star system slams into the Sun's electromagnetic domain at full speed, while every major telescope on Earth is forced to look away? The timeline, the risks, and the unknowns start right now. 3I Atlas isn't just inbound, it's inbound the wrong way. It's carving a retrograde cut, you're 5 degrees off the ecliptic, practically head-on through the planetary plane. Orbital inclination, 175 degrees. That number alone tells you it's a true outsider. When first clocked in July, its speed was 58 km per sec. Now it's pushing 68 km per second, fast enough to cross Earth-Moon distance in just over an hour. And that speed is still climbing as it falls deeper into the Sun's well. Perihelion is pinned to October 29th at 11:55 UTC at 136 astronomical unit, inside Mars's orbital distance. Closest approach happens against the constellation Virgo, but solar glare guarantees zero visibility from Earth. The orbit is hyperbolic, eccentricity 1, meaning a single pass. In, swing, out, gone. 3I Atlas is not gravitationally bound to our system. This is a one-time read on matter formed under rules not our own. From here, the timeline rules everything. The window closes as the Sun moves between us and the target. The world's largest mirrors pivot, then pause. Mission leads sign off on safing protocols, and every unanswered question about mass, chemistry, and behavior gets shoved into the dark for weeks. 3I Atlas will spend perihelion surrounded by turbulent fields we barely map well at 1 astronomical unit, let alone at an oblique angle with a retrograde cut. We don't get a front row seat, we get the playback, and that makes the reacquisition everything. October 21st, 2025. Superior conjunction. 3I Atlas slides directly behind the Sun. Solar elongation shrinks towards zero. For weeks, even space-based observatories stand down. No clever trick beats basic geometry. Those last reliable data points tumble in around October 18th. Then the gap opens. Coronagraphs like LASCO C3 and Stereo HI can't dig a mag-12, few arcsecond coma out of the corona's boiling noise without wrecking the detectors. Yes, there's shift and stack. Hundreds of frames, predictive alignment along the ephemeris. On paper, that buys a magnitude or two of depth. In practice, the corona's variability and tiny angular size kill the signal. The math is unforgiving. As the comet creeps closer to the Sun's disk, auto-safing trips. Ground telescopes, game over. Daylight and forward scatter bury everything. The Mars Vantage offered one last angle, until it didn't. So we wait. Reacquisition mid-late November in the dawn sky. Then the big check, December 19th, 2025, closest to Earth at 180 astronomical unit. Fainter than before, but now outside the Sun's glare, the ideal moment for deep exposures, polarimetry, and clean spectroscopy. Perihelion is not a suicide dive. The pass is inside Mars, not into the corona. But the solar wind, field gradients, and dusty plasma regime there can do strange things to CO₂-dominated coma. If anything unusual happens, we won't see it live. We'll see the after. Bottom line, the Sun is the perfect curtain. The best instruments blink because they must. The story pauses, not because our curiosity fades, but because physics gets the last word. Size is the slipperiest metric. With the nucleus smothered by its own activity, even big mirrors and Mars orbit cams can't resolve the core. Photometry puts it at 5 to 50 km, a range wide enough to include the largest interstellar nucleus we've ever seen. Color evolved in real time. June-July, red leaning, bigger grains and complex organics. August, vivid green, C2 and CN radicals from CO2-driven sublimation, not a water-dominated coma. That's weird for a bright, active comet this close in. Then the nickel puzzle. Spectra from both hemispheres show persistent nickel lines outshining iron. If that holds through peer review, it hints at origins like a stripped planetary core or supernova-enriched debris that somehow survived ejection and eons in interstellar space. Polarimetry goes off script. Extreme negative polarization, like sunlight bouncing off glassy or metallic micrograins instead of the usual silicates. The coma geometry adds to it. Sunward brightening, a pronounced forward scattering envelope, and an anti-solar tail that's a whisper at best. And just before the blackout, the thing got brighter. A pre-gap rise while crossing Mars's orbit. Fragmentation, a burst of volatiles, fresh crust blown off. We won't know until we see what changed when it reappears. Here's what makes this so sticky. Mass versus push. CO2 outflow estimates, on hundreds of kilograms per second, should nudge the orbit. Yet non-gravitational acceleration seems modest, implying either huge mass, tens of billions of tons, or highly symmetric venting that cancels thrust. Both are plausible, neither is comfortable. So, largest Io nucleus yet? A CO2 mountain with a metal-tinted dust signature, a forward scattering coma and negative polarization that scream, not your average comet? All of that is on the table, and the sun just took the table into another room. At Mag 12, and only a few arc seconds across near conjunction, 3I Atlas sits below coronagraph sensitivity for moving, faint coma amid the boiling corona. Stacking hundreds of frames? Great on paper. In practice, you need razor ephemerides and a sky that won't fight back. The corona fights back. Autosafing saves hardware. As separation collapses, shutters close and sensors park. Ground-based options don't exist. Even twilight hacks won't pull a Mag 12 dot from the sun's halo. Mars orbiters gave a last glancing shot, but the best instruments couldn't justify risk during peak solar angles. What can we do? Creative mining, reprocess last viable nights, predictive shift and stack along high-confidence ephemerides, run polarimetric and spectroscopic comparisons as soon as elongation returns. Did the coma composition shift? Did polarization relax? Did morphology flip? Killer metric 1. Motion. If outbound trajectory deviates in a way outgassing can't explain, that's real physics. Quantifiable dV off expected vectors. Light curves can fool. Thermal patterns can mislead. Motion is hard evidence. Killer metric 2. Polarization change. If the coma's extreme negative polarization softens after perihelion, that hints at grain size or charge, state evolution, possibly triggered by fields. If it stays extreme, more questions. Killer metric 3. Chemistry drift. If C2 to CN ratios, knee-line strengths, or CO2-H2O balance shifts, perihelion did real work on the surface. Fractures, new vents, different layers exposed. That's the kind of story spectra tell beautifully. The playbook is simple, disciplined, testable. The sun took the live show. We'll grade the after. Line by line, band by band, vector by vector, when the comet clears the glare. At perihelion, electromagnetic hypotheses get a shot. In a CO2-rich dusty plasma, charged grains can be nuded by fields and currents. If that happens, we could see polarization changes, coma shape flips, or a tiny outbound DV not aligned with venting. Some teams will also watch for radio signatures, brief charge exchange flickers when fast solar wind plows fresh gas. Nothing artificial implied, just good plasma physics. If anything lights up, it's a bonus constraint on density and flow. On the human side, astrology watchers mark the symbolism. Virgo perihelion, opposition to Chiron with Eris nearby. Jupiter, Pluto anchoring their own axis, what chart readers call a grand cross woven with a kite and trine. Whether you read it or not, it's a reminder. We project meaning into the same sky we measure. Back to the hard dates. Reacquisition in mid-late November at dawn. Closest to Earth on December 19th at WASP 180 AU. Those windows decide the paper trail. Did it fragment? Did chemistry shift? Did polarization relax? Did the trajectory pick up a tiny telling bend? Remember what got us here. 3I Atlas came in retrograde, 5 degree off the ecliptic, with CO₂-dominated outgassing, nigh heavy lines, extreme negative polarization, sunward-forward scattering, and a brightness rise into the blackout. Any one of those is notable. Together, they're a rare stack. And the mass V's push riddle will loom over everything. If outgassing thrust is modest relative to coma brightness, the nucleus is either massive or the venting is beautifully symmetric. The reacquired track will weigh in, with milliarc-second astrometry telling us if the math truly closes. If nothing weird happens, that's its own headline. A natural interstellar comet with alien chemistry but ordinary physics. If anything breaks the model, trajectory, polarization, chemistry, morphology, that's when the papers change tense from appears to requires explanation. The sun pulled the curtain. We'll read the shadows it leaves. Mid-late November, 3I Atlas steps back into the light, and every scope that can will be waiting. So the question is, do you think Atlas will be the same when it reappears from behind the sun? Drop your answer in comment and smash that like button, subscribe for the more space mysteries. Your support ensures you won't miss the big reveal.